And we are now moving to the next session called Additives, Drivers of Performance and Progress. And we are very pleased to welcome our distinguished panelists who bring extensive expertise in polymer additives and sustainability. It's Stefanie Deuser. Steffi, please come to the stage. Oh, sorry, from this side. Then we have from the US, special guest Deidre Sandrock, Director of Sustainability in Milliken. Hello. Applause to our speakers. We have Adrian Bird, Flame Retardants Advocacy and Marketing Manager at Clariant. Adrian, come to the stage. You are here. And last but not least, we have Thomas Schmutz von Songwon, who is representing Cefic as the chair of the ELiSANA sector group. Welcome,
Fange ich
Thomas.
jetzt schon wieder an?
So we will have a series of talks here, 4 different talks about additives, and we will have the opportunity for question and discussion thereafter. And the first speaker is Adrian. Adrian, please go ahead. The floor is yours. Here's your.
Thanks very much, Alexander. It's a pleasure to be here and to talk to you about additives in plastics and why we need them. And first of all, plastics are all around us and they're necessary for our modern lifestyle, so that's without question, in transportation, in electronics, in building and construction, in agriculture. That's where we need plastics and where we need durable plastics with certain performance properties. And also, 2 more examples, medical equipment or packaging, where it's not just the neat plastic that will do the job, but it needs to be enhanced with additives often. When you look at megatrends, they also support a continuous and even growing use of plastics, for instance, in urbanization, mobility, just to mention 2, or connectivity, nutrition, all these need good, high quality and high performing plastics. However, plastics are exposed to many environmental influences and impacts, like UV light, oxygen, fire perhaps, and to counter those influences, that's why you need additives in many cases. So one example is UV light. Oops, sorry, I was too fast, I think. Yeah. And that's why you need light stabilizers in plastics that will make sure that UV radiation will not deteriorate or break down the plastic. And if you want plastics that have long service life, like garden furniture on the right-hand side, and that don't degrade after 1 season or a couple of months, you need to put in certain additives that will take care of the UV irradiation. Or oxygen, antioxidants, to make sure that packaging for nutrition, so for vegetables in this case, is sufficient and really keeps away these outside influences. Or in demanding engineering environments like e-mobility that you see here on the right-hand side, also you need high performance, longevity that requires certain additives. Next, temperature and shear. Lubricants are necessary to have efficient processing of plastics, because otherwise they may stick to equipment where you do injection molding, for instance. So they ease the mold release of plastics in the processing. So things that sound simple but that really need performance chemicals that will support the use of plastics and also enhance efficiency of production. There has been a lot of talk about bio-based additives. Are they the solution? Yes, there are some instances where they really work, where it's a good approach, where, for instance, waxes that are bio-based, like based on rice brands or non-food competing bio-based materials. But bio-based additives also have limitations in that often because they come from biogenic sources, they are somewhat susceptible to water, higher temperatures, so you can't use them everywhere. But in places where it makes sense, it is absolutely fine to use them. Also, mechanical recycling needs additives often, because plastic, in contrast to metals, when you recycle metals, iron remains iron, copper remains copper. Yeah? There may be impurities that add up, but plastic, if you mechanically recycle it, due to stress and tear, and mechanical and temperature stress, the polymer breaks down. So you need to counter, or you can counter that with adding additives called chain extenders and others that will make the processing easier and also retain the good properties of the polymers. Then lastly, fire. That's actually my area of expertise. Why do we need flame retardants for plastics? And here you see an example of a fire test. That's what you actually want if there's an exposure to a small flame source or fire that the plastic doesn't keep burning but extinguishes. Yeah, that's, say, the best case. And that's necessary because most plastics burn very well, and in high risk of applications that have some risk of ignition of fire, it makes sense to add flame retardants to make the product safe. But flame retardants are not used in all plastics, not at all. Yeah, they're only used in those where there are specific and often legal requirements for fire safety. Yes, and now coming to a somewhat different topic. How many additives are there in plastics? And there has been word of, oh, there's thousands and thousands of chemicals and we know next to nothing about them. Yeah? No, that's not really true. When you scan the literature, the scientific literature or patent literature, you find more than 13,000. There's other databases that come up with more than 18,000 chemicals. Yes, these chemicals have been maybe researched. Some of them maybe have been in commercial use, but not everything that's cited in the literature is really in commercial use or in significant quantities even. So this is a breakdown of a database that the international chemical industry has put together, where they scanned this conglomerate of more than 13,000 chemicals and had a closer look, and you find out that more than 2/3 of them are not actually in commercial use, really. Yeah, they may have been used in the past, may have been research products. And out of those, the vast majority, more than 90%, have some toxicology data, not a complete set. That's certainly true. But they have some tox data, and there's maybe out of those 10% where tox data is not readily available on still maybe research. So this notion of we're using thousands of chemicals where we know of which we know nothing is wrong. Yeah, we don't have a perfect picture, but we know a lot. So with that, I come to the end. Sustainability is a driver certainly for innovation. When we look at this last slide, certainly we need better toxicology information, environmental information on our products, and we as producers are gathering that. We're continuously running studies and expanding our database, and we're also looking into, as I said, bio-based materials or more easily degradable materials where it makes sense. So sustainability is certainly a challenge, but it needs to be also combined with aspects that we want. We want durable products in some cases, so something that will degrade quickly in a product that you want to use for 10 years, your car or your computer or your washing machine, doesn't make so much sense. So with that, I'm at the end. Thanks very much, and I hand over to...
We are handing over first a big applause to Adrian. Thank you so much. And now we are handing over to Thomas. Thomas, it's your turn. Please go ahead.
Thanks.
Yeah. So, good morning. My name is Thomas Schmutz. I represent ELiSANA. I'm the chair of ELiSANA, one of the associations. And I will explain later what this really means. I'm also representing one of the additive players in this market. So, being part of Cefic, we always have this disclaimer. We work with competitors in associations, and there are certain things we are not allowed to do. We are not talking about market share, we are not talking about prices, transportation costs, so don't ask these type of questions. We should not talk about it, but the associations are important. It's the only industry group where different players can work together, and it's really important for us to have this type of association. So Cefic is the Chemical Association of Europe. Really important, and representing small, bigger, very big chemical companies. It's a big job provider, the chemical industry, 1.2 million jobs, 13% of the global chemical industries are produced in Europe. It's shrinking. It's not good. So who is the biggest player in chemical production today? Yeah, it's China, of course. So Europe needs to step up. We need to make an effort to keep the industry in Europe. We still invest a lot of money, 10 million, so it's 10 billion, it's quite some money, and we want to stay. And I'm active here that the industry stays in Europe. We are the fourth most important sector in Europe, the chemical industry. So, within Cefic, the big European organization, you have also in other regions this type of association, for example, the American Chemical Council, and then you see under the Cefic the specialty department, and I'm representing today the additive cluster. Additives, we heard already my colleague from Clariant talking about additives, so I continue the talk on the additives. And I would like to explain you what we do in these associations. So the first one, European plasticizer. Plasticizers make PVC flexible. So you may see them in wire and cable, flexible wire and cable applications. You may see them in membranes, in flooring application, but an important sector is also the medical application. So a lot of tubes and so on are made of flexible PVC, and there the plasticizers are really important. The Plasticizer Association has 11 members. The next group is ELiSANA, and I'm the chair of ELiSANA, the European Light Stabilizer and Antioxidant Association. We are a small team. We are only 5 players because many of the players are in Asia, not in Europe, unfortunately. And I will talk later and give you 2 examples what this association is doing and what kind of work we are doing. Then ERCA are the rubber chemicals. So why do you need rubber chemicals? You all use maybe a car and the tire need anti-ozonants. What does it mean? The tire, the rubber of the tire gets brittle when it's exposed to ozone. And then the rubber gets brittle. So you may have to replace the tire. Today we use the tires 20,000 kilometers or so on. Before these chemicals came onto the market, you had to replace the tire much more often. And ERCA has 8 members, 8 industrial members. Then the ESPA. The ESPA are the PVC heat stabilizer organization with 8 members. And you may see here a lot of processing equipments at the K. So extruders, so to get the PVC product across the extruder, you need heat stabilizers, and this helps to maintain the properties of the PVC. Then OxoCare, carboxylic acids, a very technical term, but you all know cellulose-based polymers like the viscose and the anti-wrinkling. That's the product you need these carboxylic acids are used that the viscose is not wrinkling. And this is the smallest group, only 3 members. And the last one, PINFA, is the biggest group with 8 members, the flame retardants. And they are different clusters of flame retardants, the phosphorus-based, the nitrogen-based, and the inorganic. Flame retardants are important for safety. So if you're in a house, they are not really preventing the fire, but they give you the time that you have the 20 minutes to leave the house. And you survive. So additives are used for performance purposes, for durability and sustainability. Performance means they maintain certain properties which were designed by the polymer producer. Durability is a big topic. We want less repair. We want that the goods last longer, and they can only last longer if you use additives. We talked about the flame retardants. They give you safety. You can leave the house. You have the famous 20 minutes that you can leave the house, and sustainable because less of repair or longer lifetime. And now, at the end, I give you 2 examples. So, as I said, I represent the Light Stabilizer and Antioxidant Association. So, why do you need antioxidants? So, why do you consume vitamins? The vitamins are important for the human body, and they do chemistry in the human body, and antioxidants do the same. They protect the polymer. They do chemistry in the polymer, and they protect the polymer. So you design certain properties. Here, a pipe example. The pipe should last for 20 years and more, and it can only do that if antioxidants are present. And if you eat antioxidants, vitamin C, for instance, and you may think you live longer, I think you made a good choice. And we do the same thing with antioxidants in the polymer. So antioxidants are really vital. This is really important. And the other example, outdoor applications. So water is scarce. So we have water in tanks. The tanks stand outdoors in many countries. In Brazil, they're on the roof. They are either blue or black, and you don't want to replace the tank every year. They last for 20 years and more, and they last so long because we use light stabilizers. Or the other example, the canoe here. You do sports. This is a rotation molded canoe. If it's properly stabilized with light stabilizers, it's also lasting 20 years. So a sustainable toy where you can do your sports activity. And this is what we do with our business. And this is how we want to support you, that you enjoy these nice tools. So thank you.
Thank you, Thomas. And now
Yes.
it's your turn, Deidre. The floor is all yours.
Thank you so much. So good morning. I thought it would be good afternoon, but good morning. And I'm very delighted to be here today to talk about our lessons learned in a net zero journey. So being able to follow up, talking about additives are good, partnerships are good. This will all play a role in the overview that we have. So as Alexander said, I am the Senior Director of Sustainability and Innovation at Milliken. Milliken is a 160-year-old company where we participate in the chemical space, the flooring space, the textile space, and we have a rich history over that 160 years of sustainability being embedded in the core values of the company. And in practice, what that means is we don't simply focus on just the products we put out, but it's sustainable manufacturing, it's making sure that as a general mission statement, we strive to positively impact the world around us for generations to come with the products and services that we serve as a company. 3 years ago, I was here, Hall 1 somewhere, and we proudly announced in a press conference at that point that we had made a commitment and had validated science-based initiative targets to become net zero by 2050. We're certainly well on our way at this point. Just to level set, our targets are 50.4% reduction scope 1 and 2, and a 30% scope 3 reduction by 2030, so near-term targets, and then 90% emissions reduction into 2050. But to level set on what that means for the audience, there we go. To level set on what that means, because the emissions counting is a bit confusing and tricky. You could think about upstream emissions, downstream emissions, or the emissions that are generated throughout your own manufacturing. So when you talk about upstream emissions, think about the things that you're buying, whether it's your raw materials, purchased goods and services, packaging, that type of stuff that essentially shows up at your dock for you to be able to manufacture the products. Scope 2, think about things that you plug in, the electricity that you get. Downstream Scope 3, think about the in-use emissions associated with your products. So it might be in-use processing, it might be consumer use, it might be end-of-life associated with the use of your products. And then Scope 1 is in-use, or it's On-site combustion, think combustion of natural gas to simply fuel the manufacturing sites and make your products. What's really tricky about emissions counting is that, particularly if you look inside Milliken as a company, over 70% of our emissions fall in this Scope 3 category, upstream Scope 3. So most of the carbon that's embedded within our products show up before it even comes onto site. And so this is a really important thing to take into consideration. And I'll just click through a very example and give a few examples of putting these scopes in practice and then get to some of the lessons learned. So when we talk about emissions of the supply chain, or that upstream Scope 3, one of the things that Milliken has done has been largely trying to develop a supplier engagement strategy. Again, this is simply not pushing our problems to our suppliers, but it's working with our suppliers in a consultative type approach to be able to help them with emissions counting, emissions target settings, help them with energy strategies that they have. It also falls back on us at looking at our suppliers and our raw materials and making sure that we're making the smartest choices in the raw materials that go into our products. But again, it's not just what shows up. We also have our Scope 1 and our Scope 2 to consider. So within the past year, we spent a significant amount of time with an energy advisor to devise this strategy to be able to adopt renewable energy across all of our manufacturing sites. Additionally, Scope 1, right, the energy that we use through combustion in our manufacturing sites, we have continuous improvement programs that are in place to be able to drive emissions out, make our processes more effective, but we also look for opportunities to make stepwise changes in our manufacturing. So one of the examples is a $25 million investment that we had that fundamentally changes the energy source at our largest manufacturing site to go from exiting coal as a primary fuel source to a combined heating and power plant to make the products that our plastics business here sells out into the industry. But again, this is all kind of the emissions that we can control through our sourcing and through our manufacturing. But there's this whole notion around the things that our additives do for our customers. And as an additive supplier, it's really important for us to make sure that our additives have an outsized impact from both a performance and a sustainability standpoint for our customers. And so we are maybe even call it obsessively focused on how we can take our additives and bring value to our customers. So this is just an example, downstream focus on what our additives can do to reduce the downstream in-use processing or the end of life of the plastics that go into it. The more that we can focus on circularity as a strategy, the more that we can impact the overall end of life impact of polypropylene, as an example, as a polymer. And so we do things like work with our customers obsessively to be able to drive towards smarter packaging formats, reducing the complexity, driving towards monomaterial solutions to improve recycling compatibility. So this is, putting it into perspective of all the things that we do. So the lessons learned, and while we have many of them, I will simplify it to 6 key takeaways. And the first is really taking a holistic view at the value chain. I touched on this already, but making sure that we're focusing on our suppliers, on our customers, our competitors, making sure that we're not reinventing the wheel, but working with the entire value chain and the industries to be able to advance solutions that matter. And that's additionally the collaboration piece is sometimes the biggest impacts that you can get are through the sharing of information and best practices. Sometimes the sharing comes at maybe sharing some poor lessons learned, but it helps you really improve by collaborating. As an innovative additive company, when you have a lot of sustainability headwinds, it may seem like a total bummer for the plastics industry, but as a leader of sustainability and innovation, I actually see this as optimism and potential to be able to continue to innovate new products and collaborate with our customers. I have here a handprint mindset. So we talk about the minimizing the footprint of our products through carbon reduction, through purchased goods and services, and through our operations. But this handprint mindset is really thinking about the positive impact that your products have that simply allow your customers to avoid emissions either through decreasing the emissions, whether it's energy reduction or simply providing avoided emissions opportunities by changing into a particular different format. We talk about, as a key lesson learned, continuous learning. And when we talk about continuous learning, when I took this job many years ago, there is this notion of, if I learned everything that I'd learned when I took the job, I simply wouldn't have paid attention to the evolving technology and regulatory landscape that's important to be able to continue to drive your strategy forward. And finally, the last point that I like to make when it comes to sustainability and how you can actually drive a lot of these adoptions is really the smart business. The best sustainable things that you can put in place are the ones that are, in reality, financially the most beneficial to both you and to your customers, finding that win-win. It's said that the most sustainable solutions are the ones that are the most financially viable. And so working with customers to be able to understand how we can provide value propositions that actually provide them a competitive advantage in the market is something that's really important. So bringing it kind of all together, that's the message that we bring today, is one of collaboration, partnership. We hope that you will come and join us down at our hall, just a couple stands away, meet with me. I'll be here the rest of today, or you can connect with me on LinkedIn.
Thank you. Thank you so much. And last but not least, it's Stefanie Deuser. Please, Steffi, the floor is all yours.
Thank you very much, Alexander, and warm welcome from my side as well. The topic that I'm going to address is a bit different from what we heard before. It's about chemical regulations. And you might ask yourself, we are in the sustainability session here talking about high-performing additives, so how does that fit? But the simple reason is, if you want to put an innovative, sustainable additive on the market, but you do not have a registration, it's not worth anything. So you really have to think about the registration before innovating, before you want to have an existing chemical put to a new market. So what kind of chemical regulations are actually out there? So here I try to summarize what we have. If we looked at that map like 5 or 10 years ago, maybe we would have a handful. But nowadays, basically every country is coming up with its own chemical regulation. And if you want to place your product, your plastic additive on any of these markets, you have to have a registration and you have to be compliant with the respective local law. And while they might be similar, they are certainly not the same. But it's not just the sheer number of chemical regulations that are emerging, it is also the existing ones that are getting more stringent. So for example, if you look at the US, where you have the TSCA regulation, we find more and more use restrictions for all the chemicals that we place there. Or especially under EU REACH, so this is the chemical legislation that we have here in Europe. We see more, basically on a daily basis, new proposals from the authorities to classify our substances differently, to restrict their use, or even to ban. So a prominent example was just recently the UV328, which is an UV observer that is used as plastic additive. But it is not only the chemical regulations that give us a hard time. There's more sector-specific regulations. So, for example, you have the packaging waste regulation, you have the end-of-life vehicle regulation, or the famous Eco-Design for Sustainable Product regulation, which all aim to further enhance the sustainability of your product. Looking at the additives also to say, and that is something Adrian mentioned at the beginning, do these additives actually hamper the recycling process? Because as you all know, we want to increase the recycling rates drastically. But also when you look at sensitive applications, like for example in food contact or drinking water, there the requirements are even harsher, because this is quite close to the consumer. So there the authorities want to have a specific focus that these additives that we use in those applications are safe. And then maybe lastly to mention is the famous UN Plastics Treaty. I'm sure a lot of you have heard about. that is currently negotiated. The primary goal was to prevent mismanaged plastics from entering the environment, but now the scope has actually broadened, and a lot of countries actually have the ambition to also regulate so-called chemicals in concerns, which are basically plastic additives. So it's not clear how this will look like, but it's certainly something we have to keep in mind. So if you look at that whole landscape, you can easily lose track. So how are we going to tackle that at BASF? Here we have invented an approach which we call Rexcellence. That is basically our guide that helps us to be compliant, so that is really the basis of Rexcellence, but it is also to help our customers taking off that regulatory burden off their shoulders so that they can really focus on what they can do best. So how does Rexcellence basically work? We have a global network of experts everywhere around the globe. And those experts are experts in chemical regulation. So if something comes up new in Korea, for example, we have country experts that are aware of that, and then we can act accordingly. But we also have a lot of experts in those sensitive applications, for example, food contact and drinking water. And here in Europe, what we are currently seeing is an amendment of both these regulations, which is called for the food contact the high purity amendment, where the authorities aim to reduce the number of so-called NIAs, non-intentionally added substances. Those are impurities or degradation products. And if you can't reduce it, you have to show that all these substances are really safe for the consumer. So the more you find, the better the analytics get. You have to prove that all these substances that you find, even at really small levels, that they are safe. And similarly for the drinking water, we've now, the authorities came up with a positive list. So all these additives can be used within as a drinking water application. However, there's a certain date where we have to re-evaluate them. So we have to provide a lot of data to ensure that they can stay on the positive list. And we at BASF, we have the experts that are really working with the authorities to guarantee that. So, but as I said, so this is really the basis, the compliance part, so that we can really ensure we have the knowledge in a certain country, what is actually the regulation, and if we put the product on the market, that we are compliant. So this is for our products, but we can also offer that service to our customers if they lack the expertise, for example. So if someone buys from us, for example, outside of Europe, blends the additive and then brings the blend into Europe, actually the duty to register is on the importer. But if they do not have the capacity to do that, that is something that BASF can take that care of. As you can imagine, with all these regulations out there, the questions from the customers are increasing. So what we have done at BASF, we've looked at, or we reviewed all the questions that we've received over the years, and we generated what we call Rexcellent documents. So for standard questions like, what is the status of registration of your product? Can you confirm absence of? Are there any substances included in your product that are on the so-called automotive GATSO list? So we have prepared statements for all our products, and you can find these statements at our customer portal 24/7 available for download. So this obviously increases the customer experience quite a lot. If you have a question that goes beyond those standard questions, obviously we have a team of people that can help you answer these questions accordingly, or even provide trainings to you on different topics. For example, at the moment we have a new regulation coming up in Turkey, KKDIC. So there we can provide you and your teams support. The part that I'm actually most excited about within Rexcellence is a tool that we developed, which we call Rexzone, which we use for chemical foresight. So I told you the regulations that we have in place, they are constantly emerging. So on a weekly or sometimes even daily basis, we see something new coming up, being that the substance is added to the California Proposition 65 list, or that under REACH we have a new proposal for classification and labeling, or a new restriction. So on a daily basis, we screen all these regulatory lists and we compare that to the products that we have, and we look, is any of our products, do they contain a substance that is subject to that regulation. So on a daily basis, we are aware that something will change, and with that, we can obviously get in contact with our customers really early in the process and discuss what could be the best option. So is it finding alternatives? So there we have an excellent team of technical experts that can help you there. Or whether we say we actually disagree with the authorities' proposal and we really want to fight for our substances, so defend that they can be also used in the future. And for that, we are doing advocacy. And as Thomas and as actually all speakers said before, we can't do that alone, but we usually do that through associations, at the moment through ELiSANA, where we really try to gather together a strong narrative showing that if a substance might have a certain toxic potential, that there is no risk to human health or the environment, because it's not only on the hazard, but it really depends on how much is the exposure to a certain chemical, whether it's really a risk for you. So something that we're working on at the moment is on the benzotriazoles that you might have seen. There, the European authorities recently added 2 more substances to the so-called substance of very high concern list. This is a list in the EU that is used to prioritize the actions of the authorities. And also they have announced that they want to maybe restrict the whole class of benzotriazoles, which in our view is the wrong message, because those, and we heard that before, those are what we're dealing here with is chemicals, and these chemicals have a certain function. They need certain functional groups to perform their function within the additive, whether it's as an antioxidant or as an UV absorber. So it's really difficult to really find a complete new chemistry. So in order to prevent this regrettable substitution, we should really work with the authorities to show that a certain substance can be, or in this case, a plastic additive can be used in a certain application. And that is what we're collecting at the moment, also with the help of the entire value chain. And with that, I'm actually at the end of the presentation. I hope I could show you that chemical regulations are important if you want to market your product. They're getting more and more stringent. So it's really important to have the right expertise. So at BASF, if you buy a product from us, you're not only getting a high performance plastic additive, but we are also getting the technical service and also the regulatory insights to have a compliant product on the market. And with that, handing over to you.
Thank you so much. Big round of applause to our speakers.